Hi everybody. So in this question, we're going to look at using T-formulae to integrate this. So because we're given the substitution that t equals tan of x over 2, we know the sine of x is 2t over 1 plus t squared, and the cos of x is 1 minus t squared over 1 plus t squared, and that the tan of x is 2t over 1 minus t squared. So now what we're going to do is we're going to rewrite this integral in terms of t. But we're also going to need to replace this dx term. So if t equals tan of x over 2, we need to differentiate this to find dt by dx. And this is a standard derivative given in a formula booklet, which is 1/2 of sec squared of x over 2. And then we can use this identity to write sec squared back in terms of tan squared. And then we know that tan squared of x over 2 is the same as t squared. So now this becomes 1/2 of 1 plus t squared. And then we can make dx the subject, so dx will be 2 dt over 1 plus t squared. So if we go back to our question, we have cos in terms of t, we have sine in terms of t, and dx in terms of t. So now we can work out this entire integral using our T-formulae. So we've got 1 over 4 cos x minus 3 sine x dx. So now we've got two fractions with the same denominator, so we can multiply out this 4 and this 3, and then write it all as a single fraction. Now we can move this 1 plus t squared to the top, and factor out the 2 from this quadratic. And at this point, you can see the 1 plus t squared will cancel, and the 2's will cancel. So now I can rewrite this integral. So you can see how the T-formulae have helped to simplify this. Now I'm going to pull out the -1 to our numerator, and I'm going to factorize this quadratic. So we get -1 over 2t minus 1 multiplied by t plus 2, all integrated with respect to t. And to evaluate this, we can use partial fractions. So we'll multiply everything by this denominator, and we get all of this. So we'll let t equal -2, so we'll get -1. This t term will go, and then here we'll get -5b. So b will equal 1/5. And then we'll let t equal 1/2 to cancel out the b term. So -1 will equal 5a over 2. So a will equal -2/5. And then we can substitute each of these back into our partial fractions. So now we can pull 1/5 from here and here out in front of our integral. And we can change this negative into a positive by making this denominator 1 minus 2t. So we're multiplying all of this by -1. And now all we need to do is integrate each of these fractions. If we use the reverse chain rule to integrate this, then we'll let y equal the integral of this bigger function. So y will be the natural log of 1 minus 2t. We'll find dy by dt, and then we'll multiply this by the derivative of this inner function. So then you can see that we need to scale this y by -1/2 to cancel out the -2. And this will be the integral of 2 over 1 minus 2t. But then this -1/2 will cancel with this positive 2. So we get minus the natural log of 1 minus 2t. And then we need to integrate this fraction, and we get the natural log of t plus 2, plus our constant term k. And I'm just going to rewrite this so this negative is over here. And now we can use the division rule of logs to simplify this. And now we can write t back in terms of x by substituting this back into here. So we get this. And if we go back to our question, this is exactly what we were asked to show. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the lessons on this topic from my website, mrmathematics.com. I'll leave a link in the description below.